Now, in this topic, which is the second of the chapter on differentiation, we will focus on parametric differentiation. Now, some common engineering parametric equations are given. For example, an ellipse. In an ellipse, the parameters are x equal a cos theta, y equal b sin theta. In some engineering analysis, you can have x equal 80 squared and y becomes 280. You can also have the hyperbola, where x equals a sec theta and y equals b tan theta. For a rectangular hyperbola, x equals ct and y equals c over t. We will use all these in our topic. Then you will have better understanding. Codiodide x equals 8 into 2 cos theta minus cos of 2 theta, y equals 8 2 sine of theta minus sine of 2 theta. In some scientific disciplines, asteroid, what you have, x become a cos cube theta, y equals a sine theta. Cycloid, x become a into theta minus sine of theta, then y becomes a into 1 cos theta. So, you have differentiation being applied now. So all these parameters can be used in differentiation by using the appropriate rules of differentiation. For example, if I tell you to find dy by dx and I give you an asteroid, x equal a cos square theta, y equal a sine, and so on. So dy by dx will be equal to, by a chain rule, dy by d theta multiplied by d theta by dx. So this is a rule of a chain rule that I'm applying to find the parametric differentiation. Or I can write it as dy by dx equal dy over d theta divided by dx over d theta. Because you see, I'm having x in the form in terms of theta, y in terms of theta. So dy by dx will be, as a chain rule, it is like this, but I can rewrite it as follows also. Dy by d theta divided by dx over d theta. Also, the second derivative that is dy by dx2, is the derivative with respect to x of, like you know, dy by dx. So this will become derivative with respect to theta of dy by dx over dx over d theta. An example, find dy by dx in terms of theta if x equal 3 theta minus 4 and y equals 4 theta into theta minus 2. So x equal 3 theta minus 4 dx by d theta becomes 3. Y, so what is dy by d theta? We are going to have 4 theta squared, which becomes 8 theta, minus 8 theta, which becomes 8. So I can have it as 8 theta minus 1. Hence, dy by dx, this is dy by d theta over dx over d theta. This becomes 8 over dx over d theta. This becomes 3. I can write it as 3 more. Okay, so now let's look at another example. The parametric equations of a function are given by y equal 4 cos of 3t, x becomes 3 sine of 3t. You are required to find dy by dx and dy by dx. So here I will say y equal 4 cos of 3t. What is dy by dt? I'm going to have minus 12 sine of 3t. What is dx by dt? This 2 comes here, 6 cos of 2t. Then dy by dx, dy by dt, which is minus 12 over dx by dt, 6 cos of dt. This goes out, minus 2 sine of 3t over cos of dt. Okay, now dy by dx2 is the differentiation with respect to t of what I will have as dy by dx divided by dx by dt, which is 6 cos of 2t. Now, how will I differentiate this one? I am going to use quotient rule. And you can work this out where we can discuss further solution in the class. Okay, so let's look at another question. The equation of a tangent drawn to a point x1, y1 on curve is given by y minus y1 equal dy1 over dx1 into x minus x1. Now, I'm required to find the equation of the tangent. Drawn to the parabola x equal to tx squared, y equal 40 at a point T. So what will it be here? So at the point T, x1 become 2t squared. This, and what will be dx1 over dt is going to be equal to 40. And at the point T, y1 becomes 40. What becomes dy1 over dt? This becomes 4. Hence, how do you find dy by dx? dy1 over dt, which is 4, over dx1 over dt, which becomes 40. Therefore, this is 1 over t. So, this is a gradient. What you have just found, this is a gradient, 1 over t. Hence, equation of tangent is y minus 40 equals the gradient, which is 1 over t, x minus t squared. Now, here in this topic, the third topic, like we mentioned in the beginning, this is on implicit differentiation. So when an equation is written in the form y equal fx, it is said to be an explicit function. A function involving y and x is called an implicit function, such as, let me write y squared plus 4x equal y cubed minus 5x squared. Or sine of y plus 6x squared equal times square 1. So this is called an implicit function. It is. Sorry, it is possible to differentiate an implicit function by using the chain rule. So I'm going to write it as du by dx equal du by dy times dy by dx. So let us look at an example. So differentiate y squared with respect to x. So hence, say u equal this y squared. What is du by dy? This becomes 2y. Hence, the differentiation of your y squared with respect to x, this becomes du by dy by using the chain rule above here. This becomes 2y times dy by dx. So now we can form a rule, a formula, by saying differentiation with respect to x of a function y. This becomes differentiation with respect to y of this function y, which we already have, just like we have done here, multiplied by the dy by dx. So this is a general rule for implicit differentiation. Let us look at some examples. Two y4. So now instead of writing these, let u equal this and then you differentiate. We are going to work this out in a different manner. We are going to say, so if I say we want to differentiate it with respect to x. So then I'm going to write it as du by dx I'm just going to watch this. I'm going to take 4, I bring it in the form, this becomes 8. And when I differentiate this, 4 minus 1, this becomes 3. But then I'm going to just write dy by dx with it. And that's it. Now u equals sine of 3t. So what will be du by dx? So again, I'm going to differentiate 3 cos of 3t. But then I'm going to write dt by dx with it. Because the variable is t here. I will not have y. So let's say I have 4 ln 5y. So again, you can say let u equal. It's up to you. You can do this. Or you can do it directly also. So then du by dx become du by dy, which will be 4 over y times dy by dx. So this is kind of what we call implicit differentiation. If I tell you find a derivative with respect to x of 2x cubed y squared. So again, you can say let u equal 2x cubed and v equal y squared. So then the derivative with respect to x of 2x cubed y squared, then we are going to get into the product rule of differentiation. V du by dx plus u dv by dx, so 2x cubed, then derivative with respect to x of y squared plus y squared this will become square y 2x dy by dx plus 3y. You can also, let's say that we want to find derivative with respect to x of 3y over 2x. Here we can use the quotient rule. U equal 3y, v equal 2x. Then the quotient rule, v du by dx minus u dv by dx over v squared. So here, the derivative with respect to x, this will be equal to x and this upon further simplification will give me like this answer. Okay, so this is about implicit differentiation.